In this video, I'm going to show you how to change numbers that are written in standard form into scientific notation. Numbers that are in standard form that you want to change into scientific notation would be really large numbers. For example, the distances planets are from the sun, or distances planets are from Earth. So for example, let's take Mercury. The 58 hundreds, thousands, millions, 58 million, we want to write in scientific notation because scientific notation is a little bit easier to read. So if I have 58 million and I want to write that in scientific notation has a couple points. We're going to write it as a decimal that's greater than 1, so greater than 1 or greater than or equal to 1, but less than 10. And then we're going to multiply it by a power of 10. So to make a decimal out of this number that's greater than or equal to 1 but less than 10 would be right there. So that's going to be my decimal, 5 and 8 tenths. To get 5 and 8 tenths and turn it into 58 million, I'd have to multiply by 10 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So I'm going to multiply it by 10 to the 7th power. Now let's say, for example, I want to write this number in scientific notation. I'm still going to start with a decimal that is greater than or equal to 1 but less than 10, which would be right here between the 5 and the 8. So I'm going to start 5 decimal point 87. I want to include the digits after the decimal point up to the zeros. So notice how all the rest of these are zeros. I'm just going to use the front numbers up until the zeros. So for example, in Neptune, I would use the digits up to the 7 with a decimal point right after the 4. For this one, okay, I would only use the digits up to the 7 and put the decimal point here. Now I can multiply that decimal, going back to Pluto, now I can multiply that decimal times the power of 10. The power of 10 is not how many zeros are in the number. A lot of times people will accidentally say that this is 5 and 87 hundredths times 10 to the 1, 2, 3, 4, 5, 6, 7 because there are 7 zeros. That is not correct. It is a very common mistake. You want to do the power of 10 for how many times you would move the decimal point, because moving the decimal point once to the right is the same as multiplying by 10. So if I'm right here in between the 5 and the 8, to get to the end of the number, I would have to multiply by 10 one time, 2 times, 3, 4, 5, 6, 7, 8, 9. So it would actually be 5 and 87 hundredths times 10 to the 9th. Don't just count the zeros. It's how many times you have to move that decimal point to get to the end of the number, because every time you multiply by 10, it moves the decimal point once to the right. You may be given numbers that are also really teeny tiny to have to write in scientific notation. For example, if I was given this number, how would I write that really tiny number in scientific notation? I'm going to do the same process as I did with the really large numbers. I'm going to first start with a decimal that is greater than or equal to 1 but less than 10, which would be right there. Okay. So 6 and 7 tenths times 10. To get from the new decimal point to the original decimal point, I have to move the decimal 1, 2, 3, 4, 5, 6, 7, 8. So this isn't going to be 10 to the 8th. It's actually going to be 10 to the negative 8 because I'm moving it to the left. Starting here, I'm moving this way. The number isn't getting bigger, the number is getting smaller, which is why it is a negative number. Okay. Just like I did earlier, I want to include all of the digits that don't include 0. So if I had a number like that, my decimal would be right here in between the 6 and the 7. So 6.734 times 10 to the, in this case I have to move it 1, 2, 3, 4, 5. And this would be -5 because my number is getting really small. I don't want this to make it a really large number by moving the decimal 5 places to the right. The negative exponent shows me that I'm moving it to the left.